Hello, and thank you for attending our Solid Edge Model-Based Definition webinar today. My name is Aaron Creech, and I'm an application engineer with ProLim, located in Cincinnati, Ohio. A little bit about myself, if you're not familiar with me yet. I have over 20 years of end-user experience in the design engineering world. During that time, I've worked in the manufacturing, architectural, and automotive design industries. I built a strong working knowledge of most 3D design software such as Inventor, CATIA, SolidWorks, several Autodesk products, and obviously Solid Edge. As I mentioned, I'm currently a Solid Edge application engineer with a focus on mechanical and electrical CAD design. My career interests include generative design, additive manufacturing, and process improvement. So today we're going to be discussing the following model-based definition topics. Some of you may be asking, what is model-based definition? Others may be asking, why would we use model-based definition? And finally, how does Solid Edge leverage this extremely valuable process improvement? I'm hoping to answer all of those questions for you today. So first we're going to look at the what. What is model-based definition? So before the age of 3D models, 2D drafting files or drawings were the only way to convey manufacturing information to the shop floor for fabrication. And even as 3D CAD evolved from 2D drafting boards, the 2D drafting files were still the primary way of communicating production manufacturing information to get the job done. The design process then evolved so that the 3D model could be quickly converted into 3D views, capturing a lot of the necessary manufacturing information with just a little bit of effort from the designers, thus improving the design process and workflow greatly. But this process still had some redundancies. These redundancies can lead to several issues. Probably the biggest, in my opinion, is the prolonged development cycle. Creation of the 2D drafting detail usually takes more time than creating a 3D model itself. When you add up this time it takes to develop the model, drawings, and other variables such as opening, searching, editing, and verifying this redundant information, this greatly extends the time it takes to get the product out the door. Secondly, the manufacturing drawings can sometimes be difficult to read. Interpretation errors are also a very big problem and can lead to some costly mistakes and increased manufacturing rework time. These problems often result in decreased productivity and quality. No good. In the next few minutes, I want to show you how Solid Edge leverages model-based definition to solve some of these big challenges that many companies out there are facing today. Our goal is to reduce the need for the time and of costly redundancies in today's production process. We're going to look at leveraging synchronous technology, using some history-based or ordered models, creating 3D PMIs from 2D drawings, and how to disseminate this vital information in a more effective way, using Solid Edge model-based definitions best practices. These improvements will ensure that all members of the team have easy access to the vital information that required to get the job done. One of the best ways to eliminate some of this redundant engineering information is to capture and retain through the use of model-based definition. This allows many sectors of the team to access and share geometric dimensioning and tolerancing, materials, and assembly level BOMs. This can reduce the need for 2D drawings by capturing crucial information directly in the 3D model. Now let's take a quick look at the PMI, or production manufacturing information if you're not familiar. Solid Edge makes applying PMI dimensions very simple. Here are just a few examples of capturing the important information on both the single component as well as at an assembly level. This information can be shared and read by Solid Edge viewing and manufacturing software to assure that the parts are made to the correct manufacturing specifications the very first time. We also have the ability to export the model and PMI to JT, STEP, CamPro, 3D PDF, and HTML formatting. Now let's take a look at both PMI and model-based definitions together in a few examples. And as usual, anytime we edit a dimension in Synchronous, we're modifying the geometry on the fly. Synchronous technology takes advantage of the closed areas of the sketch to create regions that we can then use to drag and create a 3D part. By dragging the handle, we now have a 3D model. The important element here is that the 2D sketch dimensions are carried over to the 3D part and then become manufacturing dimensions that the shop cares most about. Now if you look at the Pathfinder, you will see the PMI node that captures all of this important information. In addition, PMI dimensions have adaptive view. meaning the value changes dynamically as the view is changed, always readable in any orientation. Notice that as we change a PMI dimension, Solid Edge maintains the symmetry of the part set forth by the design intent. As we turn off the PMI visibility, we're going to add another sketch directly under the part. Here, by just creating two simple lines, we can raise the middle section of the part. Again, notice how Solid Edge automatically adds the PMI dimension to reference the part. Now we're going to project some geometry to create a cutout on the bottom side of the part. Again, see the symmetry being maintained here? Most 3D design softwares require you to carefully plan out your design steps so that they can be edited in a later time. But synchronous technology allows you to have the total flexibility of the design and the edits at any time during the design process. Notice again, the PMI dimension is driving the model here and is in total control of the geometry. This is something that sketch dimensions simply don't allow for. The benefit is to having the flexible design without having to spend too much time planning for the changes down the road. As we just saw, synchronous technology has many benefits, including being ready for model-based definition. However, not everyone has adapted to this style of design and modification, and that's okay. Since Solid Edge began, it has always supported history-based or ordered design. This method of design relies mostly on the order of features as they were created, along with the necessary dimensions being encompassed at underlying sketch geometry and typically not present at the 3D model view. Even though this approach isn't as direct as synchronous technology, Solid Edge provides a way for us to easily transfer the 2D sketch intelligence into 3D PMI information. Let's take a look. Back in our assembly, we have a few parts that were designed using a history-based approach. We'll open it and take a closer look. One of the challenges with working with history-based parts, especially if you didn't create it, is how it was designed in the first place. Solid Edge has a really cool tool specifically for this. The playback feature allows a user to see the steps taken to design the part and watch the part recompute, one feature at a time. The timing of the playback can also be changed for a better understanding of the building of the part. Let's take a look at the first feature here a little closer to see the details of the definition. Here we can see the 2D sketch that was used to create the geometry and features associated to this particular feature. We can repeat this process for all of the defined features in the part. But as you can see here, multiple steps are needed to obtain the dimensionings for the entire part. Under the PMI toolbox, we have the commands at our disposal to manually add this information in, but to save time, we can also use the existing information to copy over to PMI. In this example, we can select specific dimensions to be brought over as PMI. Simply select the dimensions and Solid Edge will copy them as PMI to be used as model-based definition. As we saw before, those PMI details are captured in the Pathfinder for easy display at any time. Now, as an alternative, we could have selected all of the dimensions at one time to be copied over to speed up the process. And as you can see, just as in synchronous technology, the adaptive view is set for PMI and always readable on screen, regardless of the orientation of the part. Next, we will determine which dimensions are critical for manufacturing purposes and delete the ones we don't need directly from the Pathfinder. Adjusting the PMI dimensions in a more reader-friendly fashion is always easy in Solid Edge, as you can see here. Now, what about CAD data that wasn't authored inside Solid Edge? Many companies either receive 2D or 3D CAD data from outside of their organization, or maybe they have old data that was developed in another CAD software. The data migration tools within Solid Edge allow for users to migrate 3D models along with their associated 2D print files from several different CAD systems while keeping the interconnectivity between the two. This is an invaluable benefit for companies that still operate using the traditional engineering methods of manufacturing documentation. For those companies that want to incorporate model-based definition into their workflow, Solid Edge provides an easy way to connect the manufacturing info from the 2D drawing directly into the 3D model, which automates the PMI process. Let's check this out in action. In this demonstration, we're going to take the 2D manufacturing information and automate it into its corresponding 3D model as 3D PMI. As you can see, we have the ability to read many different types of CAD data from many other softwares. First, we'll open up the 2D drawing that has all the manufacturing detail. As part of the migration process, Solid Edge has the capability to easily read and recognize the layering structure that many other CAD systems utilize. We can also have the ability to hide these layers for easy interpretation. With one click, we're able to activate a great tool that will allow us to create a 3D model from scratch, using the information on the drawing, or in this case, connecting it directly to an existing 3D model that we opened up from alternate CAD software. Options for projection angles and which DIMs to use are also available. As we select the desired views, Solid Edge will automatically copy and paste the selected information into the 3D CAD model. As you can see, as we maneuver to different views, the information is automatically aligned. Now with one more mouse click, the information is copied from the 2D file into the 3D part, automatically attach and connect themselves to their corresponding geometry. We now have a completely parametric model that can be driven by PMI dimensions, making this once dumb model from an outside CAD software now intelligent, easy to modify, and ready for model-based definition. Now that we've shown how to gather PMI dimensions and other annotations, how can we break this information down a little further into different views and other focused information? Views can also be considered as advanced display configurations. Not only do the views specify which parts are visible, they also specify which orientation and which PMI and annotations are shown at any given time. Various model views can be captured and displayed in the Pathfinder, allowing for common tasks such as design reviews to be easily executed. In this next quick demonstration, we'll create a model view using various PMI information from an assembly and how we can quickly toggle different displays to review different states of our design process. Over in the Pathfinder, you can see the model views that have been created so far. Simply clicking on the view gives us access to apply it and see it in its configured state. With each view, the orientation and information dynamically updates. Also available is a quick view mode. This allows you to quickly and easily click through the different configurations. Now let's start with a clean slate to see how easy it is to create a new configuration. First, let's only show the components in a smaller subassembly that we want to focus on. Next, we'll orientate the model into a position that we want for a clearer display view. Now, let's place a few PMI dimensions that will represent the critical features of this block. As you can see, the same workflow and tools are used here as within the 2D draft environment. While detailing the subassembly, we may want to place a height dimension between two different parts. As this comes in on the front face, maybe we want to relocate the dimension to make a little more sense. This is easy with the Move Dimension selection. There we go. We can also extract other important model properties to add to the view, such as part names, quantities, and weld callouts. Once we finalize the view orientation and PMI dimensions and notes, the final step is to create the view. We simply click the View command, give it a unique name, and specify any additional settings required. Now our new view is added to all the other views created. Now that we've gone through all the steps in Solid Edge to digitally author the definition of our parts and assemblies using 3D models, how do we now convey this information from engineering to manufacturing, or from manufacturing to supplier, without requiring them to use the same CAD software as we do? This is where Solid Edge MBD comes in. Solid Edge MBD is a group of tools that allows us to take information we have created in our model views and publish the content to widely accessible and widely used formats such as 3D PDF and HTML. In addition to conveying the Solid Edge data, other user-defined attachments such as Word, Excel, and PDF, among others, can be used to create a technical data package. One of the great tools that makes sharing this information possible is the Solid Edge MBD template editor. This template editor uses a familiar SE draft environment interface to define a configurable template layout. Templates can include interactive views of the 3D model, a view carousel to easily transition between model views, bill of material tables, and other customer-specific information. Once the templates are ready for use, publishing the content to 3D PDF or HTML is a breeze. Options when publishing include attachments, generating neutral JT or STEP 2P42 files that can be read into various other applications. This allows for manufacturers to send data downstream suppliers without sending the proprietary information or forcing the supplier to maintain the same version of matching CAD softwares to share files and collaborate. Password protocols can also be enabled to keep that special sauce safe. Within the Solid Edge interface, inside the PMI tab, you'll notice that both the template editor and the publishing tool. Selecting the template editor will take you back into the familiar Solid Edge drafting environment. All of the familiar drawing and sheet setup tools are available for easy template creation. Oftentimes, companies want non-accessible, editable items placed on a background sheet. This option is also available here. The first thing we're going to drop into our template is the Siemens company logo or image. Just as in a standard drawing template, these images can be inserted and resized to fit the desired area. As we decide how to format both the viewing area and other relevant information, you'll notice that added tools MBD offers. We'll start by adding the 3D view, which allows direct interaction with the model views. A simple drag of the view allows us to reposition suitable for our template. The view carousel, BOM table, and user-defined fields can be placed and edited just as easily. For purposes of time, let's open up a more detailed template that contains some additional information. You'll notice that options can be created for both assembly as well as part-specific templates. This specific template contains multiple pages, along with links to property information. As models get published, their property information, such as part number, materials, surface finish, etc., can automatically be extracted to the 3D PDF. Like the template editor, the publishing tool is available from within the Solid Edge interface. Simply specify a name and a location of the document, and finish by selecting any available options. In our particular example, we're going to attach a Word document along with a PDF to include within the data package. From there, select a Publish option and your 3D PDF is on its way. Now as we navigate the Published 3D PDF, a single click on a model view within the carousel makes available all of the information contained in that specific view. Notice that the consumers can rotate, pan, and zoom within the window interactively. Also notice that parts selected within the BOM table automatically highlight within the view. Here we are transitioning into the HTML version. As with the 3D PDF, this document is fully interactive. Other options available are interactive sectioning, as well as exploded views for a little closer look at the 3D model. I hope I was able to convey the many benefits of adopting model-based definition here today. From enhancing and reducing the design cycle by capturing the process information during the design phase as opposed to after, to reducing cost and rework, increasing productivity and quality by documenting the information once in a single source, the 3D model, and be able to use it everywhere else, within and outside of the organization. So, with that being said, I will now take questions that you may have. And as always, if there are no questions, please feel free to direct any further questions to the contact information shown here. Thank you all for attending, and thank you for your time, and have a great rest of your day.